Hello, today I will be presenting Physics 2211 Lab 5 over the fall, and I will be presenting over the falling Slinky. For a brief outline of um, the lab, for the introduction, I will present the objectives, the result preview, the key physics concepts, and the formula. For the observational model, we essentially used a stationary camera setup to analyze a video with tracker to extract positional and time data and then compare these observations with predictions from a computational model based on Newton's second law. For the computational model, we used GlowScript to provide a comparison of our experiment versus the computational one, which would provide results from an ideal situation. The objective was to model the motion of a slinky dropping from rest, compare the model to a constructed computational model, and then the bottom of the slinky, it will not move until the top falls and crashes into it, is what we're hoping. And for the key physics concepts, we have Newton's second law, which relates the net interaction between system and surroundings to the observed motion of the system, meaning that the net force acting on the system is equal to the change in momentum over time. We also have the velocity update formula, the position update formula, drag force, force of gravity, and in here that are involved in the calculations for this experiment. Here, this video was uploaded into Tracker to extract the data, which you can see here on the right. For initial conditions, we had the mass of 0.221 kilograms, an initial position of 0 meters, and an initial velocity of 0 meters per second. Now, here is the computational model, which was created using GlowScript. Here you can see the different things that we edited, such as like the magnitude of the acceleration due to gravity. And here we also have the calculation of the net force to the right, edited, and then the slinky position for the update position formula. And as a result, it gave us this to compare it off of for the data that it provided. Basically, this graph is a visual representation of the data that the GlowScript code provided. So it is the position of the bottom of the slinky versus time. Um, the yellow or the orange is the observed, and the blue is the predicted. As you can see, there's hardly a difference between the computational and observed models, which we believe the difference could be attributed to tracker error. And finally, for the analysis, the bottom of the slinky remained at a constant speed until the top falls and compresses far enough and runs into it. And the bottom is constant due to gravity and the tension on the slinky from the coils being equal to each other. And the tension force transmits downwards as the top of the slinky falls, at which point gravity causes the whole system to accelerate downwards. Thank you.